Lesson 54 is about the substitution axiom, simultaneous equations, and solving simultaneous equations by substitution. Now the substitution axiom, kind of like the trichotomy axiom, it sounds complicated, but it's really quite simple. The substitution axiom essentially says, when we know the value of a variable, we are able to substitute that value into the equation or expression to solve, simplify, or evaluate. Please take a moment to copy that into your notes. Let's move on to our first examples for today. Here we're going to use the substitution axiom in order to use substitution to solve for x and y. Now in this problem, we're given simultaneous equations. We're given a system of equations here. We've got two different ones. They make up a system. And we need to figure out what the value of x is and what the value of y is. Now in order to do that, here, what this says, we know what x is. X is negative 3y plus 11. So wherever we see x in our first equation, we're going to substitute negative 3y plus 11. Then we can solve. So we're going to get 2 times negative 3y plus 11. Remember, whenever you substitute values in, you want to use parentheses. Minus y equals 1. We can use distribution now. 2 times negative 3y, well that's negative 6y, plus 2 times 11, that's 22, minus y equals 1. Now we've got to combine like terms. Negative 6y minus y, that's going to be negative 7y, plus 22 is equal to 1. We're going to subtract 22 from both sides, and that'll leave us with negative 7y is equal to negative, 1 plus negative 22, or 1 minus 22, that's negative 21. So if we have negative 7y is equal to negative 21, we're going to divide by negative 7 to get y by itself, divide by negative 7, and we've got our answer. Y must be equal to positive 3. Because a negative divided by a negative, that must be a positive. So y is equal to negative 3. We still need to figure out what x is, because it said solve for x and y. So to solve for x, we know y is 3. So wherever we see our y in our second equation, we're going to use that one because it automatically tells us what x is. So x is going to be equal to negative 3 times 3, because that's y, plus 11. Negative 3 times 3, that's negative 9 plus 11. And negative 9 plus 11, that's x. So x must be equal to 2. And we've got our answer. We could report our answer just like this, with our x boxed and our y boxed, or an alternative would be to say 2, 3 as a coordinate pair. That would mean x first, y second. We could box or circle that one and move on to our question. Our next question, or our next problem. Choice is yours there if you want to say x equals 2 and y equals 3, or if you want to report using a coordinate pair. We're going to move on to our next slide. Alright. We want to use substitution to solve for x and y. Here we have a different one. 2x plus 3y equals 5. And it says x equals y. This is a nice one because if x is equal to y, then wherever we see x, we can substitute in y to help us find our values of y. So 2 times y, because we're substituting y in for x, because x is equal to y. 2y plus 3y is equal to 5. 2y plus 3y, that must be 5y. So 5y is equal to 5. Divide by 5. Divide by 5. Well, y must be equal to 1, because 5 times 1 is 5. So we've got our first answer. We could box that one. Now this is a fantastic problem, the one you hope for, because x is equal to y. So if x is equal to y and y is 1, then x must be equal to 1. And we've got our final answer. That question, even though it might have looked complex, was actually quite a simple one to solve. So we could report our answer like that, or we could say 1, 1, put it in parentheses to show it's a coordinate pair. We can box it or put a circle around it, and then we can move on to our next question. Using that substitution axiom, where we can substitute our values in to help us solve, is key when we're trying to use substitution to solve for different values. Lesson practice is on page 222. Make sure you've got your notes complete, and I'll see you during our next class.